In this lecture, we will discuss lifecycle rules in Terraform, but before that, we will get an overview about the differences between mutable infrastructure and immutable infrastructure. When we talk about something that is mutable, we talk about something that can be changed or updated after its creation. So for mutable infrastructure, you can continue making changes and updates to the existing object, and there is no need to recreate it with the new configuration. In contrast to mutable infrastructure, we have immutable infrastructure. When we talk about an infrastructure object that is immutable, we talk about an object that can't be changed, updated, or modified after its creation. So if you have some changes or updates to apply, you can't apply them to the current object. The only way to apply them is to destroy the old version of the object and to create a new object with the updated configuration. So we have two types of infrastructure: mutable infrastructure that can be changed and updated continuously after its creation, and immutable infrastructure that cannot be modified after its creation, so the only way to update it is to destroy the old version and then recreate it with the updated configuration. Terraform treats the infrastructure as immutable. So when we make a change to the configuration of a resource and then running the Terraform apply command, Terraform does not update the existing version. Terraform will first of all delete the old version and then create a new one with the updated configuration. But this is not always the desired behavior. In some cases, we want a new resource to be created before deleting the old version. The way Terraform behaves for updating existing resources can be changed using the lifecycle meta-argument, which is a block that can be nested within any resource block regardless of the type of the resource. We have 4 lifecycle rules in Terraform, and we will discuss them one by one. We will discuss first of all the create before destroy lifecycle rule. We will understand what happens when we set the create before destroy argument to true through a practical example. We have here the configuration file needed for creating a file called file.txt with the content welcome to Terraform inside it. So by running the Terraform apply command, a file called file.txt will be created containing the text welcome to Terraform. If we change the file name argument, for example, to welcome.txt instead of file.txt, and we apply the configuration file again, Terraform will first of all destroy the old version of the file and then create a new file called welcome.txt with the same content. But let's say that we are unhappy with this behavior. So we want Terraform to create the new file first before deleting the old version of the file. We can achieve that by adding the lifecycle meta-argument block inside the resource block of the file, and inside this block we will set the create before destroy meta-argument to true. And this will tell Terraform that we want to reverse the default order when Terraform perform an update operation for this resource. Now when we run the Terraform apply command, Terraform will reverse the default order followed for updating the resource. So Terraform will first of all create the new file with the updated name and the same content, and then delete the old version of the file. This can be beneficial if you have, for example, a server running your application and you want to make some changes to the server with Terraform. So it is better to tell Terraform that the new server must be up and running before deleting the old version of the server to avoid any downtime of your application. Let's move now to the prevent destroy lifecycle rule. The prevent destroy meta argument will allow you to protect resources from being destroyed by preventing Terraform from applying any plan that would destroy the infrastructure object associated with this resource. For example, if we have a file created by Terraform and we have the prevent destroy meta argument set to true, when we run the Terraform destroy command to destroy the existing infrastructure object, Terraform will prevent the plan from being applied, and it will throw an error indicating that the local file can't be destroyed because the prevent destroy meta argument is set to true. We will get the same behavior if we try to make a change to the local file, for example, changing the file name from file.txt to let's say count.txt, and then running the Terraform apply command. Terraform here will generate the same error for the same reason. The only way to destroy a resource object having the prevent destroy meta argument set to true is either by removing this meta argument from the resource block or by removing the resource block from the configuration file entirely, which will lead to removing the prevent destroy setting along with it. And this can be handy when you want to protect critical resources managed by Terraform, such as database instances from being deleted accidentally. Let's see now how to work with the ignore changes lifecycle rule in Terraform. After creating a resource with Terraform and making some changes to the configuration, when running the Terraform apply command, Terraform will compare the current state of the resource object to the new configuration, and it will try to update the resource object as mentioned in the configuration file. We will talk about state in Terraform later in more details. The ignore changes feature is intended to be used when a resource is created with data that may change in the future but should not affect the resource after its creation. For example, here we have this configuration file containing a resource block for creating a file called welcome.txt containing the text welcome to Terraform. And we have the ignore changes meta argument set to a list containing just the file name attribute to tell Terraform that any change made to the file name attribute must be ignored. When we run the Terraform apply command, Terraform will create the file as mentioned in the configuration file, and if we change the file name in the configuration file, for example from welcome.txt to welcome to terraform.txt, while running the Terraform apply command, Terraform will display a message indicating that the infrastructure matches the configuration, even if the file name was changed. That's because we have told Terraform to ignore any changes made to the file name argument using the ignore changes meta argument. You have to note that only attributes defined by the resource type can be ignored. For example, for the local file, you can ignore changes made to the file name or to the content argument or both of them, but we can't ignore changes made to meta arguments, which are the arguments that can be used with any resource type, like the depends on meta argument, for example. Finally, we will talk about the replace triggered by lifecycle rule. The replace triggered by lifecycle rule can be used when you want to replace a resource whenever a change is made to a group of resources or resource attributes. Let's understand that in more details. Let's say that we want Terraform to generate a random integer and to create a file. Then, whenever the content of the file was changed, we want Terraform to generate a new integer which will replace the old version. For example, if the content was changed from 15 to 25, Terraform must recreate the file with the new content, and the random integer must be replaced also. Let's see how to achieve that in Terraform using the replace triggered by lifecycle rule. We have here the configuration file needed to create a file and to generate a random integer. In the source block of the random integer, we will add the lifecycle meta argument, and we will set the replace triggered by meta argument to a list containing only a reference to the file name attribute of the local file. When we apply this configuration for the first time, Terraform will create the file and generate a random integer. Then if we take the same configuration and we change just the content of the file from 15 to 25, now by applying the new configuration, Terraform will first of all delete the old version of the file and the old version of the random integer, and then it will recreate them using the new configuration. So here we didn't change anything related to the random integer, but by applying the new configuration, Terraform delete the old version of the random integer and generate a new integer, and that's because we have told Terraform that the random integer must be replaced anytime the content of the file was changed. And that's done using the replace triggered by option of the lifecycle meta argument. If we set the replace triggered by option to a list containing a reference to the file and not a specific attribute of the file, the random integer will be replaced whenever a change is made to any attribute of the file. So anytime the file name was changed or the content was changed, the random integer will be replaced. So that's it for now. I hope that everything is clear, and thank you very much.